Okay, so this is a titration curve of lysine, but before I get into how I made this, here are the different stages lysine goes through during its titration. So first we have this untitrated lysine here at stage A. This here is below a pKa of 2, but then when we reach a pKa of 2, labeled here as X, we then get stage B here, where the carboxylic acid group has been titrated and the molecule has lost this proton here. And then over here, when we get to a pK of 9, labeled as Y, the lysine molecule is then titrated again. This time the amine group here loses its proton, and then over to a pK of 11 labeled as Z, and we're then left with stage D, where this last amine group here has lost the third and last proton. And now that we have all of that, we can move on to the curve itself. Here we have A and B at a pK of 2 at the inflection point here. And then here at X, we have the equivalence point here when we have about 1 equivalent of OH added, hydroxide. And then over here at B and C, we have the the second inflection point here. And then here at Y, at 2 equivalents of hydroxide, we have this next equivalence point. And then at C and D here, labeled in green, we have the third inflection point. And then here at Z, we have the third equivalence point here. And, oh, I forgot to mention that this inflection point here is at a pKa, or I'm sorry, a pH of 9. And this one, the C and D, is at a pH of 11. And the equivalence point here has 3 equivalents of OH added.